The first session on inequations. Inequations based on factorization. I have a question for you here. The answer is yes, it is sufficient. Did you get that? Did you get that in like 30 seconds? If not, don't worry. Wait for this video to complete and then come back and solve this again. You will definitely be able to solve this in like 20 seconds. Before we delve deeper into this type, let's have an overview of inequations in general. Inequations are expressions involving the following signs: greater than, lesser than, greater than or equal to, and less than or equal to. Remember, in inequations, do not cancel the variables on right-hand side and left-hand side. For example, if 2x squared is greater than 5x, it does not mean that 2x is greater than 5. Next, cross multiplication is not a valid operation on inequations. For example, if 2 divided by x squared is greater than x divided by 8, it does not mean that 16 is greater than x cubed. Remember, all of this is so because we are not aware of signs of these variables. For example, imagine if x equals negative 10, 2x squared equals 200, and 5x equals negative 50. Therefore, 2x squared is greater than 5x in this case. But see, in 2x is greater than 5, the value of 2x would be negative 20, which is not greater than 5. So to avoid these cases, it's best to not cancel the variables on the two sides or to cross-multiply. Remember, addition and subtraction are valid operations on inequations. For example, this inequation. The right way of solving this would be to have all the variables on one side and then factorize. Okay, so this operation is perfectly all right. Similarly, this one. You can have all the variables on one side. You can have 1 divided by x minus 3 divided by x is greater than 10. This is a perfectly fine operation. Now that we have covered the basics, let's concentrate on the topic inequations based on factorization. To understand the concept, let's take a very elaborate example, such as this one. Such a big expression will not appear on the GMAT, but for conceptual clarity, let's take this complex example. If you can solve this, you can, of course, solve the easier ones. So, if this expression is greater than 0, which of the following specifies all the possible range of values of x? This is the question. Let's see how to solve these questions. The concept is that, in such questions, factorize the terms and equate each factorial to 0 to get different nodes. So this is what the expression is. This can be factorized into x minus 2 times x minus 3 times x plus 6 times x plus 5. This entire expression is greater than 0. Now the concept is that you have to equate each term to 0 to get the nodes. The value of this polynomial would be 0 for 4 different values of x, the 4 values for which each of the 4 terms becomes equal to 0. These values are 2, 3, negative 6, and negative 5. The next step is to represent these nodes on the number line. These are the 4 values, and we have to think of what happens to the sign of the polynomial as per these values on the number line. Now imagine these 4 terms are being multiplied: x minus 2, x minus 3, x plus 6, and x plus 5. The smallest of these values is x minus 3, represented by this node, 3. So in this range, when x is greater than 3, what happens? The smallest of these 4 terms, this, becomes positive. If this becomes positive, the other 3 also, of course, become positive, and therefore the value of the product is going to be positive. At x equals 3, the value of the product will, of course, be 0, because one of the 4 terms becomes 0. Next, between 2 and 3, what will happen? X minus 3 will become negative, while the other 3 terms will remain positive. So effectively, we will have 1 negative sign and 3 positive signs, leading to a negative value of the polynomial. At 2, x minus 2 will become equal to 0, and therefore the value of the product would be 0. Now, between positive 2 and negative 5, what would happen is that x minus 3 would be negative. X minus 2 will also be negative, 2 negative signs and 2 positive signs, because the other 2 terms will continue to be positive. So the product, two negative signs times two positive signs, effectively lead to a positive value. Next, x equals negative 5 is a value where x plus 5 will become equal to 0. And in this range, between negative 5 and negative 6, x plus 5 will become negative. X plus 6 will remain positive, while the other two terms will also be negative. Overall, we now have three negative signs and one positive sign. Effectively, we will have a negative value in this range. Lastly, below negative 6, all the four terms will become negative, and therefore, practically, we will have a positive sign, a positive value of the polynomial. So the graph would look something like this. See rightmost positive and then alternate negative and positive signs. Okay, so the question seeks positive values of the polynomial. The answer would be x is greater than 3, x is between negative 5 and positive 2, or x is less than negative 6. These are the possible values. Important tip: to save time, simply mark the rightmost region as positive. This area will always be positive, and thereafter, you will have alternate negative and positive signs. Let's take some examples. Look at this one. Please pause the video, draw it yourself. The three nodes involved are 0, 1, and 6. That is when one of the three terms become equal to 0, respectively. Then you know that rightmost you will have a positive sign, and then alternately negative and positive signs. So this is what the graph looks like. Positive, negative, positive, negative. The question is asking for negative values. Therefore, the required ranges are x between 1 and 6 and x less than 0. Please pause the video, solve it yourself. Bring all the terms on one side. Now factorize. Then draw it on the number line. The two nodes are at positive 3 and positive 4. Draw it. Rightmost area is always positive. And then alternate negative and positive signs. The question is asking for positive values. Therefore, the required ranges are x is greater than 4 and x is less than 3. That's the required answer. Some practice questions. Look at this one. These are your answer choices. Please pause the video and solve it yourself. Let's draw these nodes on the number line. The values on which the expression becomes equal to 0 are negative 3, 0, and positive 2. Rightmost region would always be positive, and then alternate negative and positive signs. The question is asking for positive values of the polynomial. Therefore, the required ranges are x is greater than 2 and x is between negative 3 and 0. Remember, there is an equal to here, so we can put equal to sign, but we have to be careful that values for which denominator becomes equal to 0, we should not have an equal to sign. So we can have the equal to sign here. We can also have the equal to sign here, but we cannot have the equal to sign here because otherwise the denominator will become equal to 0. The required answer is x is greater than or equal to 2, and x is greater than or equal to negative 3, but less than 0. E is the correct answer choice. Look at this one. Please pause the video and solve it yourself. It's a DS question. Statement 1 simplifies to x minus 2 times x minus 6 is greater than 0. When we draw it on the number line, we have 2 and 6 as the nodes. Rightmost area is positive, then negative, positive. We look for positive values of the expression, and therefore we have this value. X is greater than 6 or x is less than 2. In either case, x cannot be equal to 4. So statement 1 leads us to no as an answer. Statement 1 is sufficient. Look at statement 2. This simplifies to x minus 2 times x minus 4 is greater than 0. Let's draw this one as well. Nodes are 2 and 4. Signs are positive, negative, positive. So either x is greater than 4 or x is less than 2. Still, x is greater than 4, but not equal to 4. Therefore, this also leads us to no as an answer. Statement 2 is also sufficient. The answer is D. Second topic under inequations, inequations based on modulus. I have a question for you here. Did you get yes, it is sufficient, and that no, x is not greater than 0? Did you get that in like 30 seconds? If not, don't worry. Concentrate on this video and come back to solve this question again. I'm sure you will be able to solve this in 30 seconds. The basic concept involved in such questions is that when you see such a question, something like, if mod x minus 2 is greater than 3, what is the possible range of values of x? What you have to do is to ensure that you open the mod. But remember to take the positive as well as the negative case. So if mod x minus 2 is greater than 3, it means either x minus 2 is greater than 3 or x minus 2 is less than negative 3. A very important case, the second one. Imagine if x minus 2 equals negative 4, then mod negative 4 equals 4, which is greater than 3. Hence, one case is that x minus 2 is greater than 3, and the other case is that x minus 2 is less than negative 3. Very important, often missed. So there are two cases. X minus 2 is greater than 3, leading to x is greater than 5, or x minus 2 is less than negative 3, leading to x is less than negative 1. Therefore, the required answer is x is greater than 5 or x is less than negative 1. This represents the possible range of all values of x. The next case is this one, when modulus of something is less than something else. The concept involved here is that in such cases, the value has to lie between two values. Imagine if mod x plus 5 is less than 10, x plus 5 has to be less than 10. But it cannot be so less than 10 that it becomes less than negative 10, because in that case, such as negative 11, mod negative 11 will become 11, which is not less than 10. So very important. For this, x plus 5 must lie between 10 and negative 10. So it has to be less than positive 10, but it has to be greater than negative 10. So when you open the mod, we say greater than negative 10, but less than positive 10. And now solve it. 5 goes on the left, negative 10 becomes negative 15, and when positive 5 goes on the right, 10 becomes 5. So negative 15 and 5 are what x must lie in between. This is the required answer. Now, with this learning in place, let's look at some examples. Find the range of values of x. Please pause the video, solve it yourself. 2 minus x is greater than 10 is one case, or 2 minus x is less than negative 10 is another case. So, in this case, we get negative x is greater than 8. In this case, we get negative x is less than negative 12. So this becomes x is less than negative 8. Crucial. Please remember, when you remove the negative sign, when you multiply both sides with negative 1, the inequality always reverses. For example, 2 is greater than 1, but if I multiply both sides by negative 1, see, negative 2 is less than negative 1. The inequality must reverse. So similarly, x is greater than 12 here. The right answer is x is less than negative 8 and x is greater than 12. A small tip I will give you here is that in the correct answer choice, when you put these values in the inequality, the values on the left-hand side and the right-hand side must become equal. For example, the answer choice says x is less than negative 8. Put negative 8 here in place of x. You get 2 plus 8, which is 10. See, 10 and 10. The two sides have become equal. Similarly for 12 also. Mod 2 minus 12 is mod negative 10, which is 10. So see 10 and 10. The two sides have become equal. Okay. So for example, if there were an answer choice, which said something like x is less than negative 7, when you put it here, you see that the left-hand side and right-hand side have not become equal. And therefore, such an answer choice which involves a boundary, such as negative 7, is not going to be correct. The next question. Please pause the video, solve it yourself. Mod 10 minus x is less than 20. We can say that negative 20 has to be less than 10 minus x, which in turn has to be less than 20. 10 goes this side. It becomes negative 30 is less than negative x. When 10 comes this side, this becomes 10. And now, when we multiply the entire thing with negative 1, it becomes negative 10 is less than x is less than 30. That is the right answer. Look at this one now. Please pause the video, solve it yourself. This is the less than case, and therefore the value of the expression inside the modulus has to be less than the value outside the modulus and greater than the negative of the value outside the modulus. Now let's solve it. On the left side, imagine negative x and negative x will get cancelled. 20 is always greater than negative 10. Therefore, there is no limit on the left-hand side. It's only the right-hand side that decides the value of x. So 20 minus 10 equals 10. X goes there. It becomes 2x, and therefore x is greater than 5 is the only answer. It is the only range of values for x. That's the right answer. The third topic under inequations, inequations based on signs. I have a question for you here. Did you get B as the answer? Did you get that in less than 30 seconds? If not, complete the video and come back to this question. Let's start from the basics. Positive times positive is positive. Negative times negative is positive. Positive times negative is negative. Positive to the power of even is positive. Positive to the power of odd is also positive. Negative to the power of even is positive. And negative to the power of odd is negative. Very, very basic concept, but beautiful questions can be made on it, especially in inequations. So let's get on to learning by examples. Look at the first question here. It's a DS question. Please pause the video, solve it yourself. The right approach in all these questions is to try to get a yes as well as a no for each statement. When you cannot get both yes as well as no, that is when a statement becomes sufficient. Statement 1. For something like x equals 1 and y equals 1, the answer would be yes. And for something like x equals 1, y equals negative 1, the answer would be no. So see, both the pair of values are satisfying the given condition, but are leading to different answers, yes and no, for the question, and therefore statement 1 is not sufficient. Look at statement 2 alone. Now, for cases such as x equals 1 and y equals 2, we are getting yes as an answer. See, 3x minus 2y would be negative 1 in this case. This condition is being satisfied. For xy is greater than 0, the answer is yes. And for cases such as x equals negative 1 and y equals 2, again, look at this. 3x minus 2y would be negative. And now, the answer to this question, whether xy is greater than 0, would be no. So once again, we have been able to get a yes as well as a no. So statement 2 alone is also not sufficient. On combining, you will realize that cases such as this, where x is positive and y is negative, would not satisfy the second statement, because such a value would always lead to a positive value for the second case, whereas the second statement requires a negative value. So such cases can be eliminated. And you will realize that cases such as this, where x is negative and y is positive, will always lead to negative values for 3x minus y, whereas statement 1 says that 3x minus y should be positive. So such cases can also be discarded. Further, statement 1 could be sufficient in cases such as this, where x equals negative 1, a small negative number, and y is a big negative number, such as, say, negative 10. 3x is negative 3, and negative y is positive 10, and that is why the sum becomes positive. But if this were the case, this combination would not satisfy the second case, because in this case, 3x minus 2y would be even more positive than 3x minus y, and therefore for such combinations, 3x minus 2y will never be negative, and therefore such cases cannot be taken because they do not satisfy the second statement. Therefore, the cases which are left are cases such as these two, where x and y are both positive. If x and y are both positive, the product xy is going to be always positive. Therefore, on combining, we can say that yes, xy is greater than 0. We had to combine to get a consistent answer, therefore the right answer is option C. Look at the next question. Please pause the video, solve it yourself. It is a DS question again. Once again, the same approach. Try to get a yes as well as no. So for p equals 2 and q equals 3, we get no as answer. For p equals 5 and q equals 4, we get yes as answer. No and yes, both are possible. So statement 1 is not sufficient. Statement 2, q squared is bound to be positive and the product is negative. Therefore, this definitely tells us that p is something negative, However, still, for p equals, let's say, -2 and q equals -1, we get no as answer. And for p equals -3 and q equals -4, we get yes as answer. Again, yes and no, both are possible. So statement 2 is also not sufficient. On combining, these cases have to be discarded because these are all positive cases. We know for sure that p is negative, and if the product pq is positive, then q should also be negative. Now on combining, we know that p and q are both negative, but we don't know which one is more negative. For this case, we will continue to get no as an answer. See, this pair of values is satisfying statement 1 as well as statement 2, and this pair of values is satisfying statement 1 as well as statement 2. In one, we are getting no as an answer. In the other, we are getting yes as an answer. So, even combining is not helping, and the answer is option E. Once again, the approach in these questions is to try to get a yes as well as no, and therefore you must choose values which, while satisfying these conditions, lead to a yes as well as no. When you are not able to get both yes and no, when you get either yes consistently or no consistently, that means you have an answer and the statement is sufficient. So in this case, we could get yes as well as no for statement 1 alone, for statement 2 alone, as well as on combining the two statements. Therefore, even combining did not help, and E is the right answer. Look at this one. There are 4 expressions, and these are your answer choices. Please pause the video, solve it yourself. The approach in maybe questions is to simply get one example in which the condition is satisfied, and then you can select that statement as correct. So let's try to prove each of them possible through any one example. So statement 1 is possible for something like -0.5. See, -0.5 is the lowest. -0.5 cubed is -0.125. That is also negative, but lesser negative, and therefore greater than -0.5. And see, -0.5 square would be positive 0.25, greatest of the 3 values. And therefore, statement 1 is definitely possible. Statement 2 is not possible. See, we try all type of values. For any big positive number, x cubed would be greater than x square. So a big positive number, anything above 1, will not satisfy. Anything between 0 and positive 1, in this case x to the power of 4, will be the smallest and not greatest. So this cannot satisfy. In -1 to 0 range, you will figure out that x squared will be greater than x to the power of 4, and therefore this is also not possible. In the range below -1, something for x is less than -1, x cubed will be smaller than x. It will not be greater than x. So even in this range, it is not possible. See, we have taken all the 4 cases, something above 1, something between 0 and 1, something between -1 and 0, and something less than -1. None of them worked. So statement 2 is definitely not possible. Look at this one. This is, of course, possible for big negative values such as -2. See, -2 cubed is -8. -2 square would be positive 4, a small positive number, and -2 to the power of 4 would be a big positive number. So this is, of course, possible. Students often ask me that, how do I imagine these numbers? How do I come up with these examples? So a lot comes with experience. A lot of it is natural bent for numbers. And then there is always this option of trying different values in all the 4 ranges. Range above 1, between 0 and 1, between 0 and -1, and below -1. Look at the last one here. This would be possible for, again, a big negative number. See, -2 cubed and then -2, a relatively smaller negative number. -2 squared would be a small positive number, and -2 to the power of 4 will be a big positive number. So this is also possible. Statements 1, 3, and 4, D is the correct answer choice. Look at this one. Please pause the video, solve it yourself. It's a DS question here. It's given that PQ divided by RS is negative. That means either one of the 4 values, P, Q, R, and S are negative, or 3 of them are negative. Let's look at statement 1. It simply says that denominator is greater than the numerator. It doesn't say anything much. Statement 1 is not sufficient. Look at statement 2. It says that Q is negative, R is negative, and therefore the product QR is positive. and therefore this case can be discarded. It's not one of the four which are negative. So 3 of the 4 have to be negative for this expression to be negative. Now 3 are negative. 2 are already negative. That means out of P and S, any one is negative and the other is positive. Therefore, this product, PS, has to be negative. Negative times positive equals negative. QR is positive. PS is negative. And therefore, QR is greater than PS. We are able to reach yes as an answer using statement 2 alone. Therefore, B is the correct answer choice. The fourth topic under inequations. Inequations based on -1 to 1 range. Look at this question. The answer is cannot be determined, because for x equals 2, the answer is yes. For x equals 0.5, the answer is no. Let's start from the basics. Some interesting observations. Look at the first one. 1 divided by x. We tend to think that if x is positive, for example, if x equals 10, then 1 divided by 10 will be less than 10. This changes, however, in the range of 0 to 1. Example, 1 divided by 0.5. Now see, 1 divided by 0.5 is 2, which is greater than 0.5. Similarly, for negative numbers, we think that 1 divided by -2 will be greater than -2. But this changes in the range 0 to -1 because 1 divided by, let's say, -0.5 becomes a bigger negative number. This becomes -2, which is, of course, less than -0.5 itself. It is for such observations that it is important to understand that the range of -1 to +1 behaves very differently. This was the case of 1 divided by x. Let's consider x squared. Generally, for a big positive number, say 10 squared, the squared value is greater than the number itself. But see what happens in the range 0 to 1. 0.5 squared is less than 0.5 itself. Similarly, look at x cubed. 10 cubed would of course be greater than 10, but 0.5 cubed would be much smaller than 0.5 itself. In case of negative numbers, see -10 cubed, which is -1000, is much smaller than -10 itself, because this is a much bigger negative number. However, in the case of the range -1 to 0, -0.5 cubed, see this becomes -0.125, which is much smaller a negative number compared to -0.5 itself. Therefore, -0.5 cubed is greater than -0.5 itself. Root x. We tend to think that if you take root of a value, say square root of 4, the value reduces. See, 2 is of course less than 4. So on taking square root of 4, the value reduced. However, think of a number such as 0.5, again in the interesting range of 0 to 1. When you take square root of this, the value does not reduce. The value increases. This would be approximately 0.7. Some very interesting observations. This range of -1 to 1 is very important in inequations, especially if you are plugging in values to find your answer. Do not ignore this range of -1 to 1. Ideally, while plugging, you should take one big negative number, something which is less than -1. Call it -1 minus. Take one value between -1 and 0, take one value between 0 and 1, and then take one value which is above 1. Only when you have explored all the 4 ranges should you reach a conclusion. So let's get on to learning by examples. Look at the first example here. Please pause the video, solve it yourself. These are the answer choices. Now, intuitively, if x is greater than x squared, x cannot be negative. And generally, x squared is greater than x. It's only in this range of 0 to 1 where x is greater than x squared. Therefore, E has to be the correct answer choice. Doing it more mathematically, you can do it this way. X squared minus x is less than 0. So x minus 1 is less than 0. I hope you have seen the factorization-based inequations video. The two nodes are 0 and 1. Rightmost region is positive. And then alternate negative and positive signs. The question is asking the negative values. So this is the range. X has to be between 0 and 1. That's our answer. However, more intuitively, we know that x cannot be negative from this. Then generally, x squared is greater than x. It's only in this range that x is greater than x squared. That was an easy question, difficulty level 1. Let's move to the next one now. This is the question. There are 3 statements, and these are the 5 answer choices. In maybe questions, you should look for just one example that satisfies the condition, and then you can select that statement as correct. For example, in the first one, this may be true for a very small positive value of x, such as x equals 0.2. 1 plus 0.2 equals 1.2, which is greater than 0.2 itself, and 0.2 is greater than x squared. X squared is going to be a very small value, 0.04. So statement 1 is possible. Look at number 2. This would be possible for a big negative value of x, such as x equals negative 2. Negative 2 squared, which is 4, would be the greatest. 1 plus negative 2 would be negative 1, smaller than 4. And 2x would be negative 4, which would be the smallest of the 3 values. So this is also possible. And the third case would also be possible for a very small positive value of x, such as, let's say, 0.1. 1 divided by 0.1 would be 10. 1 plus 0.1 would be 1.1, and 2 times 0.1 would be 0.2, a very small positive value. All the 3 cases are possible. Therefore, E is the correct answer choice. That's a high or medium difficulty level question. Let's move to the next question here. Please pause the video, solve it yourself. Here are the 5 answer choices. In the always correct questions, you must look for one example for which the statement can be eliminated. For example, the first one. For a big negative value, such as x equals negative 5, you will see that 1 divided by negative 5 becomes negative 0.2, which is greater than x, which is negative 5. But x is not greater than x squared, as x squared will turn out to be a big positive number. This would be 25. So see, the condition has been contradicted, and therefore option 1 can be eliminated. Similarly, let's try eliminating option 2 as well. For a small negative value of x, say negative 0.2, see negative 0.2 is greater than 1 divided by negative 0.2, which would be a big negative number. This would be negative 5. See, this is negative 0.2. This becomes negative 5. 2x would be negative 0.4, which is not greater than x, which is negative 0.2. So this statement has also been contradicted. This can be eliminated. Look at the third one now. For a small negative number, such as negative 0.1, x is greater than 2x because 2x would be more negative, a negative 0.2. So this condition is satisfied. But 1 divided by x becomes negative 10, a big negative number, which is not greater than x. X is a smaller negative number. So even this statement has been contradicted for x equals negative 0.1. So this can also be eliminated. Look at the fourth one now. This one is the easiest to eliminate. For all negative values, say x equals negative 2. Negative 2 squared will be greater than x because negative 2 squared would be something positive. X cubed, however, will again be negative. Therefore, this can be easily contradicted. X squared is 4. X is negative 2. X cubed is negative 8, which is not greater than x squared, which is 4. Contradicted. So this can be eliminated. Look at this one now. X is greater than 1 divided by x, either for a big positive value of x, such as x equals 5, basically a value above 1. So for all such values, you will see that square of a number greater than 1 would be greater than 1 divided by a number greater than 1 because this will be less than 1, and this will always be greater than 1. So in such cases, the condition cannot be contradicted. The condition is met. And the second case, x is greater than 1 divided by x, is met when x is a small negative number, such as x equals negative 0.2. See, x would be negative 0.2. 1 divided by x will be 1 divided by negative 0.2, which becomes negative 5, which is a bigger negative number. And in such cases, x squared will be something positive, and therefore greater than 1 divided by x, which would be something negative. So even in such cases, the condition is met. These two conditions cannot be contradicted, and therefore this is always correct. E is the correct answer choice. This was relatively a lot more difficult question to get right. This was a 700+ level question. Look at the next one now. Please pause the video and try solving it yourself. There are 3 statements, and these are your answer choices. In the can never be correct questions, the right approach is to find just one case where the condition is met, and thereby eliminate the statement. So for example, the first one. Let's try getting one example where this condition is met. So for a value such as x equals negative 1.5, this becomes 2.5. Then negative 1.5 square is 2.25. And this is of course negative, the smallest value. So see, this condition has been met, and therefore this choice should be eliminated. Look at the second one. Let's try finding one case where this condition can be met. See the first condition, x is less than x squared. This can be met for either negative values or for large positive values. But for negative values, 1 divided by x will be negative, while x squared will be positive. Therefore, 1 divided by x can never be greater than x squared. So for negative values, the condition cannot be met. For large positive values, 1 divided by x will become a fraction, less than 1. Therefore, even for these values, the condition cannot be met. And therefore, this condition can never be met. Therefore, this statement should be selected. This is what the question is asking, that for which of the following the condition can never be met. So this is a fine choice. Look at the last one now. When x is a big negative number, such as, say, negative 5, x squared is a big positive number, 25. 1 divided by x is a small negative number, negative 0.2. And x is a big negative number, negative 5. So this condition can be met. Therefore, this statement should also be eliminated. Statement 2 only is the correct answer choice. B it is. Again, a difficult question. This is a 700+ level question, I would say. Look at the next question. This is a data sufficiency question. Please pause the video, solve it yourself. The approach would be to get a yes as well as a no. Is x cubed less than x is the question. While satisfying the first condition, we want to get yes as well as no. For x equals 0.5, this condition is met. And what do we get here? We get 0.125 here and 0.5 here. So we get yes. Now let's try getting a no. For x equal to a negative small value, say negative 0.5, this condition is met. And what do we get here? This is negative 0.125, which is greater than negative 0.5. So we have got a no as well. We got a yes as well as a no, while satisfying the given condition. So statement 1 is not sufficient. Now let's look at statement 2. While satisfying this condition, let's try to get a yes as well as a no. If you see closely, the same pair of values will work for this one also. X equals 0.5 satisfies this condition. It gives you a yes. X equals negative 0.5 satisfies this condition, gives you a no. Therefore, statement 2 is also not sufficient. Statement 1 was not sufficient. Statement 2 is not sufficient. Combining is not going to help because the same pair of values that we took, incidentally, worked in eliminating both statements 1 and 2. Combining has not worked, and therefore the correct answer choice is option E. This was a medium difficulty level question,